Good day to you. So today we are looking at speed, and our objective questions are: what does speed refer to? What is the unit of speed, and how can you calculate or find speed? These questions are based on the objectives that we have to master by the end of this topic. So remember, our topic is speed. All right, so on this page, as you can see, we have some worked examples that we will go through before we do some calculations together. So that means we're going to go to page 73 of our science book and look at the worked examples together. Here we are in our textbook on page 73, the PDF version. And as you can see here, we have Marcus rides his bicycle at a speed of 4 meters per second for 60 seconds. How far does he go in this time? Marcus rides his bicycle at a time or speed of 4 meters per second for a time of 60 meters per second. How far? So our question is, how far does he go in this time? So there are three things we have to make sure we know. So here we are in our whiteboard. Is 4 meters per second. Then our time is equal to 60 seconds. And what are we looking for? Because we only have three things in our calculation that we can look for. We have speed, we have time, and the last one is, yes, distance. So we are looking for distance, or how far. Now, we can create our triangle of information so that we can remember how to write our formula. Therefore, at the top, we have distance, which is the one we're looking for. We have time at the bottom and speed at the bottom. So as I said, we are looking for distance. We do not have distance. Therefore, when we write our calculation or formula, we say D equals to S multiplied by T. And when we do it this way, we can see easily that on the left-hand side, we have their information. And what I like to do is in brackets, I put them all together. So in brackets, I create my bracket, 4 meters per second, and I put the units with it because that reminds me what my final answer unit should be. And 60 seconds. Now, what will the final answer for this be? We will take 4 multiplied by 6 and then add a 0 at the end. So if you remember primary school math, you will get an answer of 240. 240. And remember what happens to the seconds? They cancel out and we're left with meters. So that's your final answer. Now we have another example. So therefore, let's jump back into our textbook and read what that one says. We have Sophia is in a car traveling at a speed of 35 meters per second. How long will the car take to travel 2,100 meters? All right, so let us jump back into our whiteboard so that we can see how to do it ourselves. 35 meters per second as her speed equals to 35 meters per second. And what's the other information we had for her? We also knew that her distance was 2,100 meters. Now I realize that it's all in the textbook, but it's always good for us to practice on our own because sometimes we can make little mistakes if we don't practice the easy things. So what's missing? Speed, distance. And this time we're looking for what? Yes, time. All right, so time is the one we're looking for. Now, once again, we create our triangle so that we remember where everything is. Distance, time, and speed. And which one are we looking for? Time. So are we going to multiply or divide in this case? Of course, we will divide. So therefore, time equals to distance divided by speed. And our distance is 2,100 meters divided by our s, speed, which is 35 meters per second. And therefore, our final answer will be, who knows? I will give you a moment to go into your calculator and find out for yourself. Yes, your answer will be 60 seconds. Well done. So remember your quantity or the number, which is first the size, and your unit, which comes second. They're very important. All right, now that we have completed our worked examples, we can go back into our challenge to see if we can do those questions on our own. And there are 3 questions that we will do. Right, so we're back. We have finished our worked examples and we've done them together. So the next part is, Marcus loses energy and slows down to 2 meters per second for the next 60 seconds that he rides his bicycle. How far will he travel now? So remember, we calculated a distance for Marcus first, and now the distance will change because his speed changes. All right, so Sophia gets into a different car, which travels at a speed of 60 meters per second. How long will the new car take to travel the same distance? And then the last one is, an aeroplane travels back over the 2,500 kilometers and a further 800 kilometers for a time of 8 hours. What is the new speed of the aeroplane in kilometers per hour? All right, so we're back in the whiteboard, and as you see, I have our worked example here that we did before. But now our challenge is the speed of Marcus has changed. So this is not 4 meters per second anymore. It has changed. So therefore, we write our new speed equals 2 meters per second, and our time is still the same at 60 seconds. Now, some of you who are very fast will already know what the answer will be, but remember, in science, we try to be accurate and show all our work. Therefore, we have to go through the whole process again by writing everything we need to know. Distance is the one we do not have, so therefore we're still calculating distance. So d equals s multiplied by t, and this means our new speed will be 2 meters per second multiplied by 60 seconds as before. And then we will have 6 multiplied by 2, which is 120 meters. Because remember, what happens to our s's? They cancel out. Let's go to the next one. So welcome to the next part, where we already have the worked example we completed for Sophia. And our new information for Sophia is that she gets into a car with a speed of 60 meters per second. So therefore, we have to change our information. S equals to 60 meters per second, and we have 2,100 meters. And we're still calculating or finding time. Therefore, we still write our formula and say t equals to distance over speed, which equals to distance of 2,100 meters divided by 60 meters per second. And this will equal to what number? Right, very good. The number we get is 35 seconds. Yes, because in this case, the meters will cancel each other out, and we will be left with only seconds. Right, so our last work example that we have not done yet is an airplane travels 2,500 kilometers in the time of 5 hours. What is the speed of the airplane in kilometers per hour? So here you can see we're looking for time again, and we divide the distance by the time, 2,500 kilometers divided by 5 hours, and this gives us 500 kilometers an hour. So let's see if we can find the important bits in this question. We have a time of 5 hours. We have a speed that we are searching for because we do not know what the speed is. And we have a distance of 2,500 kilometers. When we look at our next example, remember these different numbers. Here our last challenge is an airplane travels back over the 2,500 kilometers and a further 800 kilometers for a time of 8 hours. What is the new speed of the airplane in kilometers per hour? So we do not just have one distance, but two distances. Therefore, we have to do something with them. I'm going to give you a moment to try and figure out what you have to do in this question. All right, so as usual, we will go through the worked example first. Here, we have a distance of 2,500 kilometers, a time of 8 hours, and we do not know the speed. We're trying to find the speed. So our formula will be S equals to distance divided by time. And our distance is 2,500 divided by a time of 8 hours. When you calculate this, you will find that it is 312.5. So 312.5. And what's our unit? Kilometers per hour, because those are the units that we have been using. But this cannot be our final answer. Our final answer has to be in two significant figures. So that means we have to change the 312.5 to 310 kilometers per hour. And this is something that you will learn on the first week that you come to school about significant figures and SI units. Right, but moving on to our challenge. In our challenge, if you remember, we had two distances. We had a distance of 2,500 kilometers and we had 800 kilometers. All right, and our time stayed the same at 8 hours, and we are still looking for S, which is speed. So we redraw and redo our formula triangle, because we always have to put our formula so that we make sure we know what's going on. That means we're still looking for S, and S equals to D divided by T. But this is where it will be different. So for this distance, we don't have only one distance. We have to add the 2,500 kilometers with the 800 kilometers, right? And then we divide it only by 8 hours. So how much will this give you? This gives you a final answer of 412.5 kilometers per hour. So remember what we did before. We also had to find the significant figures. So therefore, in this case, we also have two significant figures, and that means that we will change this to 410 kilometers per hour. Oh, excuse my M. There you go. This is our challenge, to have more than one distance and what to do with it. It will be the same for more than one speed or for more than one time. You always want to find the difference between the two or the total amount of the two. For distance, you will find the total amount that is traveled. For time, you will find the difference between the two. And for speed, you will also find the difference between the two. Well, that's it for our calculation challenge, but there's something important to remember. Always remember, unless you are told otherwise by your question, always work in meters per second. And the base units will therefore be meters and seconds. So if you get values in other numbers, you have to change them to your base units. And the second part you have to remember is calculations should always show the steps you used when working out the answers. So write everything that you do step by step. And the second thing is include the correct units in your answer, because no units means no grades or no marks. In physics, it's not like math. We have to add the SI unit at the end of our answer. So always remember that. All right, so lastly, here is some homework that you can use to just test your knowledge about speed and to know what you know. And therefore, if you have a problem with one of these questions, you can always approach your teacher and ask about it, or point them to the question that is confusing you. I hope you have a great day and that you enjoyed this video. Bye.